Good morning, Doctor. We are students from BTK 2213. Today, we're going to give a presentation about our mini project with title Friction Loss in Various Types of Flow. So first, let us introduce ourselves. I'm Chu Chai with metric number KH19026.
My name is VINHUR with KH19015.
My name is THANG with matrix number KH19030.
So first, let me start with the introductions of our project. We as engineering technologists, we learn about fluid mechanics. In fluid mechanics, we know that fluid that flowing through a circular pipe, energy will lost. So let me list the objectives of our project. First is to determine the Reynolds number. Second is to calculate the friction factor. Third is to determine the types of flow, whether it's laminar or turbulent. And then to calculate the fluid friction loss in circular pipe using GUI. And lastly is to compare the difference in friction loss due to different diameter of circular pipe is used. So we talk about friction loss. The friction loss is due to the frictions in the length of pipeline, so energy will lost. So we call this as head loss. And then this head loss can be calculated by using the Darcy-Weisbach equations, as shown in the slide. L is the length of the pipe between tappings, and then D is the internal diameter of the pipes, V is the velocity, G is the accelerations, and then F is the friction factor. So let's proceed to Reynolds number. We have to calculate the Reynolds number in order to know that whether the types of flow is laminar or turbulent. If your Reynolds number is less than or equal to 2100, it means that it's laminar flow, and then if it's greater than 2100, it indicates that it is turbulent flow. So the Reynolds number can be calculated by using the equations shown on the slide. V is the velocity, D is the diameter of the pipe, rho is the density of fluids, and then mu is the viscosity of fluid. Laminar flow and turbulent flow are important because we have to know we can apply different formula of friction factor in these different types of flow. So for laminar flows, we're going to use Darcy friction factor. And then the equations are expressed as F equal to 64 over Reynolds number. And then for turbulent flows, we know that it is affected by the wall roughness of pipe. Therefore, Swamy and James have developed the Swamy-James equations to solve the friction factor without iterations, where F is the Darcy friction factor, E is the roughness of the pipe, D is the inner diameter of the pipe, and then also including the Reynolds number. So in our mini project, we set up a program with GUI, and then this GUI, which is the MATLAB graphical user interface development environment, it provides a set of tools to create graphical user interface. Then we add additional commands, which for the if-else functions, selection menu, and graphical techniques. For if-else functions, it is used to assign one object or another depending on whether the first argument or test is true or false. And then followed by the selection menu, which causes a menu box to appear on the screen with a series of buttons that defined by the programmer. And then lastly, it reaches the graphical techniques, which enable us to know the trace of the result. So the problem statements in our project, there are two problem statements. First, which is there any difference between normal MATLAB functions and GUI in calculations for friction loss? And secondly, is how to create GUI that is related to friction loss of fluid that we learned before.
Next, I will proceed to the flowchart of this project. To start, we have to choose the exact diameter of the pipe from the menu, which included in 0.001 meter until 0.006 meter. Then we have to key in the physical properties of water, density and viscosity at 5 degrees Celsius, as well as the velocity of water. The Reynolds number will then be calculated, and the type of flow, whether it is laminar or turbulent flow, will be determined. If turbulent flow is determined, we have to key in the roughness value of the pipe in order to determine the friction factor. The final step will be inserting the value of length of the pipe to calculate the friction loss. Next. For the steps of creating the program, first and foremost is to create a blank UI, then create edit text box for all inputs and create static text box to label all the inputs and all the outputs. Then create panel to group the text box that will be showing the calculated answers. 3 push buttons will then be created to calculate Reynolds number, friction factor, and friction loss. A push button to plot bar graph will be created. Subsequently, change the tag name of each box. Next slide. Next, we'll be opening the M file of the figure created by pressing the editor button on the bar menu. Type the commands to each input under their callback components and change the string type to number type for each edit box. Add the formula under callback components for respective push button for calculations. Set function will be added so that the calculated value is shown on the static box. Add plot bar graph function under callback component for push button to plot the graphs. The last step will be save and run the M file.
So right now I'll be presenting about the result and discussion. So as you can see from the slide, it is showing the GUI system that we developed earlier. Next, several function is used in this mini project. Firstly is the switch menu function for when selecting the inside diameter of the pipe, and also when selecting the bar graph that we have to plot. Next, subplot function in order to group all the bar graph we plotted, and also if else function in order to determine the type of flow, whether is it turbulent flow or laminar flow. So in this mini project, we'll be taking the case as water at 5 degrees Celsius. So the physical property of water at 5 degrees Celsius, such as viscosity and density, are 1.519 times 10 to the negative 3 kg per meter second and 1000 kg per meter cube respectively. So the velocity of the flow inside the water flowing inside the pipe is 0.9 meter per second, and the total length of the pipe is equals to 9 meter. And in this case, stainless steel pipe is chosen. Therefore, the roughness of the stainless steel pipe is equals to 0.002 times 10 to the negative 3. So right now, let's move on to the demonstration for the calculation. Right now, I'll be demonstrating on the calculation by using the GUI system that we developed. Firstly, we have to press the run button. A new MATLAB window will be pop up as shown. So in order to calculate the Reynolds number, first we have to key in the physical property of the water at 5 degrees Celsius. So for density is equals to 1000, velocity of the water is equals to 0.9, and viscosity of water at 5 degrees Celsius is 1.519 times 10 to the power of negative 3. So we'll be choosing the inside diameter of the pipe as 0.001 meter. So to calculate the Reynolds number, we have to press the push button, and as you can see, the Reynolds number is equals to 592.495, as it is less than 2100. Therefore, the type of flow is equals to laminar flow. So next, we will be calculating about the friction factor by pressing the push button, and the friction factor we obtain is 0.108018, and because the type of flow is laminar flow, and hence the roughness of the stainless steel pipe is not required. So next, we have to key in the length of pipe, which is 9 meter, and to calculate the friction loss, we have to press the push button, and the friction loss we obtain is 40.1351. So next, we move on to a different inside diameter by pressing the push button again, and we'll be determining the friction loss at 0.004 meter. So to calculate Reynolds number, we have to once again push the push button again, and the Reynolds number we obtain is 2369.98. And because the Reynolds number is greater than 2100, therefore the type of flow is equals to turbulent flow. So since it is turbulent flow, we have to key in the roughness of the stainless steel pipe, which is equals to 0.002 times 10 to the power of -3. And to calculate the friction factor, we once again push the push button again, and the friction factor we obtain is 0.04828081. Since the length is maintained, the length of pipe, we won't be changing anything. And to calculate the friction loss, we press the push button once again, and the friction loss we obtain is 4.47805. So a different bar graph is plotted by pressing the push button labeled as plot bar graph. So by pushing the push button, another menu will be pop up as shown in order to plot a different bar graph. So in this case, I want to plot a vertical bar graph. So I'll be pressing the first button, which is labeled as vertical bar graph. So in order to calculate the friction loss for another fluid, we can press the push button labeled as reset, and everything will be reset again, and you can calculate for another fluid, the friction loss for another fluid. So back to the slide. As we can see, when the inside diameter is equal to 0.001 meter, the friction loss is equal to 40.1351. When the inside diameter is equal to 0.002 meter, the friction loss we obtain is 10.080338. And when the inside diameter of the pipe is equal to 0.003 meter, the friction loss is equal to 4.45943. Next, when the inside diameter is equal to 0.004 meter, the friction loss is calculated to be 4.51719. When the inside diameter of pipe is equal to 0.005, the friction loss is equal to 3.3503. And lastly, when the inside diameter is equal to 0.006, the friction loss is equal to 2.62989. So from the slide, as you can see, a different bar graph is plotted by using the plot function built inside the MATLAB. So that's all for me.
I will proceed to the conclusion of this project. This program can be used to calculate the friction loss in circular pipe for various types of flow, and the differences in friction loss for different diameters of circular pipe can be compared by using 4 types of graph. For determination of Reynolds number and type of flow, the properties of liquid included in density and viscosity as well as velocity are required after selecting the inside diameter provided in the menu button. The Reynolds number which less than or equals to 2100 indicated laminar flow, whereas Reynolds number which greater than 2100 indicated turbulent flow. For determination friction factor, Darcy friction factor equation will be used for laminar flow, while Swamy-Jain equation for turbulent flow with the values from roughness of pipe, inner diameter as well as Reynolds number. For determination of friction loss, which is calculated by Darcy-Weisbach equation with the values from inner diameter, length of pipe, velocity of liquid, acceleration due to gravity as well as friction factor. The commands used in this project included graphical user interfaces, GUI, if-else function, selection menu as well as plot function. In short, the program showed that the highest the diameter of circular pipe, the lowest the friction loss. There are few recommendations for this program. One of the recommendations is to create an improved GUI that can display the friction loss in variation geometries such as rectangular duct and square duct. There is only circular pipe included for our current project. The variation geometry should be considered as well, where friction loss in other geometry can be determined. Furthermore, the inside diameter of the pipe should be improved so that it was not only limited to 6 different values, it would be taken more inner diameter values for consideration. Moreover, there are only selected values for properties of liquid were considered in plotting. The values for properties of liquid available for the comparison graph should be increased. That's all from us. Thank you.